Hello, I'm Kate, and in this video we are going to be working on significant figures, rounding and standard form. The unmanned Ariane 5 space rocket exploded just 40 seconds after takeoff after a 10-year development program costing $7 billion. It was all due to a rounding error. These things really matter. And yes, you may say, well, if I don't round correctly, I'm not going to be responsible for a space rocket exploding. Probably true. But if you can't do these things, you don't know how to present your answer. And it's the difference between you getting a question wrong and you getting a question right. It's a topic that I'm passionate about because I see so many students who have never been told the importance of presenting their final answer correctly. They've never been taught to know how many significant figures an answer should be given to unless they are told in the question. This is something that's basic. You need to get to grips with it so that you can move on to working on more complex things without always worrying about, is your answer in the right format? We are going to begin by looking at significant figures. In everyday life, in maths, when we look at data, many of the numbers that we use are not exact. A significant figure is any digit in a number which we are confident is correct. When you are making measurements, you should not be recording data to more significant figures than you can measure. If you do, it's wrong. It implies an accuracy that you simply don't have. How do we count the number of significant figures? Quick recap here. Hopefully this is something that you should be able to do already, but let's check. So you begin counting at your first non-zero digit, and if it's a whole number, you stop counting at the last non-zero digit. There's 3 examples here. I'd like you to pause the video and have a go. Pause now. Let's take a look at how you did. So, your answers are given here, the number of significant figures. Let's show you how I got those answers. So this is our first digit. We have 1, 2, 3 digits. Nice, easy, straightforward one. That's 3 significant figures. How about the next one? We've got a 0 on the end. Well, if it's a whole number, zeros are not significant. They don't count. They are simply there to give us the correct powers of 10. So this 0 does not count towards your significant figures, giving you 3 again. Final example, we start counting on the 3. So 1, 2, we get to a 0, but there's another digit after it, so we keep counting. So that gives us 4, final 0, discounted again, as it's simply there as the power of 10. If we are using decimals, you need to remember that zeros after a decimal point are significant. They don't need to be there to give us the power of 10. They are there because they are significant. So if there's a decimal point in the number, stop counting at the last digit after the decimal point. So here you go. 4 examples for you to try. Pause now. Let's take a look at how you got on. So here you go. These are the correct number of significant figures for each of those. If you didn't get that, let's have a quick look at why those are the right answers. So first example, first non-zero number, 1, 2, 3, 4, 5. These zeros are significant, giving you 5 significant figures. Here again, first non-zero number, 1, 2, 3, 4, 5. That 0 again is significant. Okay, this is the first time we have looked at a number that starts with 0. That is therefore discounted when we do our significant figures. That is simply there as a placeholder to give us the correct powers of 10. So that is our first digit, the 4, 1, 2, 3, 4 significant figures. Here we have to discount the first 3 zeros, giving us just 3 significant figures for this answer. Right, let's have a look at rounding. This is something that you always need to think about when you give your answer. To begin with, let's look at rounding to 3 significant figures. So this is our number, okay? The first thing you do is find the position of the last digit that's going to be rounded. So 1, 2, 3, that is our last digit. And then we look 1 to the right. If it is less than 5, we round down. If it's 5 or over, we round up. So this is over 5, so we round up, giving us 56.4. And that is to 3 significant figures. Okay, here's some examples for you to try. Pause now. Let's take a look at how you got on. So rounding each of these to 3 significant figures, these are your answers. We have 1, 2, 3. The 3 is less than 5, so we round down, giving us 32.4. Here, 1, 2, 3. The 7 is greater than 5, so we round up, giving us 657. We need a 0 on the end because this is a whole number, okay, and that gives us the correct power of 10, so 6,570. Here, that is our third significant figure. The 1 rounds it down, giving us 3,200. So let's have a see about how we use significant figures in calculations. To begin with, we're going to look at the type of calculations that involve addition and subtraction only. Okay, so no multiplication, no division, otherwise it's a different rule. In this case, if it's only addition and subtraction, you need to round your final answer to a calculation to the same number of decimal places as the least accurate piece of data in the question. So let's take a look at the example. Here we have 1 decimal place. Here we have no decimal places. This is the number that you get out if you type it into your calculator. We need to give it to no decimal places so that it matches the least accurate piece of data. That's our last number. This rounds it down, so we get 554 to 0 decimal places. Okay, 3 examples for you to try, all addition or subtraction, so it's the number of decimal places that matters. Pause now. Let's take a look at how you got on. Here we go. These are the answers that you should have got. Let's take a look at why. Here we have 0 decimal places, 0 decimal places. So we round our answer to 0 decimal places, meaning that actually the first one we don't need to do anything to. Second example, we have 3 decimal places, 1, 2, 3, 4 decimal places. The least accurate one is 3, so we need to round our answer to 3 decimal places. That's our third decimal place. The 5 rounds it up, giving us 0.298. Here we have no decimal places, we have 1 decimal place, so we need to round to no decimal places. So that's our last number. The 5 rounds it up, giving us 480 to 0 decimal places. This is going to be what you do far more frequently. Most calculations will involve multiplication or division. In this case, the decimal places are irrelevant. It's the significant figures that matter now. But it's the same principle. You look at your data and you see which is the least accurate in terms of the number of significant figures, and that tells you how many significant figures to use in your answer. So if we take a look here, we have 3 sig figs, we have 2 sig figs. You need to give an answer to 2 significant figures. That is your second significant figure. That rounds it up, so it becomes 2.0 to 2 significant figures, matching your least accurate piece of data in your question. Okay, I would like you to use the same principle here. I've given you the answer to the multiplications. You need to now round it to an appropriate number of significant figures using the data to tell you what that is. Pause now. Okay, let's take a look at the answers. This is what you should have got. Let's go through why. We have 3 significant figures, we have 1 significant figure. You need to round to 1 significant figure. 6 rounds up, giving us 600. Next example, you have 4 significant figures because that's after a decimal. 2 significant figures. You need to round to 2 significant figures. That's your second one. The 4 rounds down, giving you 7,800. Here you have 2 significant figures, and we have 3 significant figures. Again, you need to round to your least accurate one of 2. That is your second significant figure, and the 5 rounds it up, giving you 3.1 to 2 significant figures. This is really crucial. You need to always give answers as decimals, not fractions. I often see students who haven't been told the importance of this. If you give an answer as a fraction, it will be marked as incorrect because it implies an accuracy that you don't have. A fraction is an exact number. We need to think about significant figures, remember. We're not giving all of those digits because we don't know them. If we look here, we have 2 significant figures and 1 significant figure. You can only give an answer that's to 1 significant figure. This fraction is to far more than one significant figure. So when your calculator gives you an answer in that format, you need to press your conversion button so that it converts it to a decimal. When you do that, this becomes this number. But what's this? We have a dot on it. That is a recurring sign. You must never give an answer with a recurring sign in it because this says 666666. Well, there's all those digits there, but we don't know them. We didn't have those digits in our data, so we can't give an answer that has all those digits there. So never, ever, ever give a recurring sign in your answer. What you need to do is round this number to the right number of significant figures, which is one significant figure. So that is the significant figure. That rounds it down, giving you an answer of 0.04 to 1 sig fig. This is what you need as your answer, not that. Please take this on board. It is so important. Okay, top tip for you. When you go on to use your answer in further calculations, you've got to think really carefully about how you do that. You've gone through this. You now know how to give your answer. You're rounding it correctly. You're giving it to the appropriate number of significant figures. Brilliant. But you can't use that rounded number in the next part of your calculation. Otherwise, you're going to accumulate errors. And it means that your next part of your question, your answer is likely to be incorrect because you've used a rounded number. You need to use the exact numbers in your calculations. So what you write on paper is the rounded number, but what you put back into your calculator is the exact number. Easiest way to do that is don't put the number back into your calculator. Use the answer button on your calculator, and that puts in the exact number for the next step. Now, if you're doing more complex calculations, it may be that you need to work out something else and then come back and use that earlier answer, in which case you're going to need to learn to use the memory function on your calculator. Calculators usually have several memory functions so that you can store these important numbers as you're doing it, meaning that they're then there, ready for you to use, no rounding errors. You're going to carry on and get your answers correct. Really, really important. So round on paper, but use the unrounded number in any further parts of a calculation. Final thing that we need to look at then, before we pull it all together, is standard form. Now, this is something that you should be used to using from GCSE Maths or Science, but let's have a recap. Now, I've given it in the form of x times 10 to the power n. This sometimes puts people off, but it's really easy. Don't worry about it. X is simply a number between 1 and 9. So let's say we have 2 times 10 to the power of something. N is simply telling you how many decimal places to move your decimal point. This can be a positive number if it's a large number, so 2 times 10 to the 5, and this would make it a large number. Or it can be a negative number if we have a small number, so this could be 2 times 10 to the minus 5, in which case we would have a small number. So x, number between 1 and 9, this simply a number telling us what we do with the decimal place. Let's put that into practice. If n is positive, so 5.7 times 10 to the 3, you move the decimal place, that number, to the right. So here we're moving the decimal place 3 places to the right. So it was here and it's gone 1, 2, 3, giving us 5,700. If n is negative, it's telling us to move the decimal point that number of places to the left. So 5.7 times 10 to the minus 3. Well, the decimal place was here and it's gone 1, 2, 3 to the left. Okay, a couple of examples for you to try. Pause now. Let's have a look at how you got on. These are what your numbers should be. So let's have a look at how we got those numbers. N is positive, so we're moving 4 places to the right. So 1, 2, 3, 4. So that gives us 48200. Don't put the decimal point in because otherwise it's giving you significant figures that we don't have. So let's just check. So it was here, that'd be 1, 2, 3, 4. So that's correct. Minus 2, we're going 2 places to the left. So 1, 2, giving us 0.0124. Let's just check that. It was here, it's gone 1, 2. That's correct. If you're going the other way, converting from decimals to standard form, you need to put the decimal point after the first non-zero value in the number. So you only have one digit to the left of the decimal point, and then count how many decimal places you've moved it. If it's gone to the left, then n is positive. So here we are going to put the decimal point in here after the first digit. It was here, it's gone 1, 2, 3, 4 to the left, so 2.57 times 10 to the 4. Conversely, if your decimal point has moved to the right, then n is negative. So we have a number that's less than 1. So it's a decimal going 1, 2, 3 places to the right to put it in here after your first non-zero digit. So 5.68 times 10 to the minus 3. Okay, over to you. Pause now. Let's take a look at the answers. This is what you should have got. Let's check how we should have got that. So we are going to put a decimal point in here. It has moved 1, 2, 3, 4, 5 to the left. So 3.5 times 10 to the power 5. Decimal point here, well, we are going to move it here instead, meaning that it's moved 1, 2, 3, 4 places to the right. So 4.5 times 10 to the power minus 4. Quick thing to talk about is how you get numbers in standard form into your calculator, because this is something that sometimes trips people up. You have a special button. Some calculators it's EXP, some it's written as times 10 to the power x. Whatever it is on your calculator, this is what you use to get a standard number in standard form easily into it. So let's say I have 6.2 times 10 to the power 4. I am going to type into my calculator 6.2. Then I press the button at this point, so whichever one you've got, and then I simply enter the power. Okay, so 4. If it's a minus, I can use the plus minus button to put in that little minus. And that's it, you're ready to use it. Easy peasy. Okay, final thing to pull everything together. You've got to be able to use standard form with the appropriate number of significant figures and any rounding that you need to do. So, 2 examples here. I would like you to give the answers to these in standard form, rounded to the appropriate number of significant figures. Remember to look at the data to tell you what that is. Pause now. Right, let's check out the answers. These are the answers that you should have got. Let's see how you should have got those. First of all, let's check out significant figures. So we have 2 sig figs, we have 2 sig figs, answer needs to be to 2 sig figs. So this is what we get out. We need to use that as the second significant figure. This is going to round it up, so giving us as an intermediate 3, 3, 0, 0, 0, 0, 0. Putting a decimal point in after that first one and then counting how many places it's moved to the left. It's gone 1, 2, 3, 4, 5, 6, giving us 3.3 times 10 to the 6. That's to 2 sig figs, like our data. Okay, this time we're dividing by a very large number. This is Avogadro's number for people who may recognise that. Right, because it's so large, we're going to get out a really, really small number, which means the calculator will already give us the answer in standard form. But we need to work out what format to write this down in. We need to do significant figures and rounding. So here we have 3 sig figs, here we have 3 sig figs. So we need our answer to be 3 significant figures. That is our third significant figure. This rounds down, simply giving us 2.04 times 10 to the power minus 22. Now, you've finished the video. Well done. I hope that's cleared up a few things, or at least reminded you of what you need to be doing. Like I said earlier, it is really crucial that you know how to give your answer in the right format. It's the difference between being right and wrong, and that matters. With maths, you do need to overlearn things. If you're at all rusty on any of those points or any of it was new to you, then please go and try the consolidation exercises. That will help you to embed the knowledge, meaning that you can then use it without having to think about it so hard the next time you do a calculation. Thanks for working with me today. Bye.